Good morning, dear students. Welcome back to RV online class. In previous class, we have completed exercise 3.5 up to 1st May. In previous class, we have solved that true or false. Okay, the statements are given. We have to write true or false. We have done in previous class. Okay, in this session, we will start the second question. That is, here are two different factor trees for 60. Write the missing number. Factor trees, here, see here. Factor trees. Trees means like, these are the pictures like tree. So that's why it's called as a factor tree. Factor means we are taking the factor of 60. 6 tens are 60. We know that already we have learned what are factors. How we have to find factors. For example, the factor of 4, 1, 2, 4. So these are the factors of 4. We now have learned factors, multiples and so on. Okay, so the factors of 4 is 1 in one table, the 4 is coming in two tables, the 4 is coming, and in 4 tables the 4 is coming. So that is nothing but factor. The number is divisible by this number, the 4 is divisible by this number, so this is nothing but factors. So here, yes, here the factor 3 means, so it is called as factor C. 6 tens are 60. And we have to write the missing numbers in this thing. Okay, we have to write missing numbers. So let's see. See here, 6 tens are 60. The factor of 60 are 6 and 10. Next, we have to find the factor of this 6. Here already was given 2 into dash is equals to 6. 2 into dash is equals to 6 means we have to multiply to such a way that we will get 6. So 2 how much is 6? Yes, 2 3s are 6. So this missing 3 we have to write in this blank, this circle. Okay. So 2 3s are 6. So these are the factors of 6. We have to take factors up to, we will get a prime number. See here, 2 is prime number, 3 is prime number. If we will divide, if we will take the factors of these prime numbers, we will get same numbers. See here, if we will take this 2 into 1, if we will take this again 2 into 1. So we have to stop here only. Up to we will get prime numbers. Okay, we have to stop here only because here we know that 2 is a prime number. If we will take factors, we will get only two factors, that is 2 and 1. We know that. So don't take factors of these prime numbers. We have to stop here only. Okay, keep in mind we have to stop here only up to prime numbers. 2 is prime number, 3 is prime number here. Next, 2 into dash is equals to 10. 2 how much is 10? 2 how much is 10? Yes, 2, sorry, 5. 5 how much is 10? Yes, 5 2s are 10. So in this blank, in this circle, we have to write 2 because 5 2s are 10. Okay, here 1 is given, one prime number is given, another prime number is, we don't know. The factors of 10 are 5 and 2. So 5 2s are 10. Okay, here what we are observing? Yes, 5 is a prime number and 2 is also a prime number. So we have to stop here only because if we will take the factors of 5, we will get 195 only. And here also, if we will take the factors of 2, we will get same 2 and 1. So we have to stop here, prime number. Here next, this is the part A. Next, coming to the part B, same the factors of. We have to take anyway. Okay, we have to stop last up to prime number. That's it. If see here, for instead of 6 and 10, take 20 into 3. 23 is 60. Okay, so 30 into 2. Okay, this is also factors. Anyhow, if you want to take like this or if you want to take 6 into 10, so you can. But keep in mind, last we have to stop at the prime numbers. Okay, so this is already given in the question, so we have to fill that only blanks. This one is this one. Okay, the already this is given. So here the second method. Okay. 30, how much the 60? Yes, 30 into dash is equals to 60. 30 2s are 60. Why this circle is stopped here? Yes, 2 is a prime number, so the factors of 2 is the 1 and the number itself. So the circle is stopped here only. Stopped here only. So 32s are 60. Next, here 30 is the not prime number. 30 is a composite number. So we have to take the factors of 30 also. 10, how much is 30? See here. 10 into dash is equals to 30. 10 3s are 30. So why is here the circle is stopped? Because the 3 is also a prime number. So we don't want to take another the factors of 3. Okay. We know that the factors of 3 is 1 and 3. So this is a prime number. We have to stop here only. 10 3 is a 30. Next, here, yeah. Here there are two lines. So 10 ones are 10. Don't take 10 into 1 because if we will take 10 into 1, then we have to take the factors of 10. So here the circle, in question the circle is stopped here only. So we have to take two numbers, prime numbers. Okay, two numbers also prime. Which are those? Yeah, 2, 5. 2 into 5 is nothing but 10. Here 2 is also prime number and 5 is also prime number. This is also called it as prime factor tree. Prime factor tree means we are stopping here with the prime numbers. We are stopping here last with the prime numbers. So this is prime factor tree or factor tree. Understood? So this is how we have to take factors of 60 in two different ways. Okay. But keep in mind, children, whatever number you want to take, but at the end you have to take prime numbers only. Okay. Solution. Next we'll move to next question, that is third question. Third question. Which factors are not included? Which factors are not included in the prime factorization of a composite number. In the prime factorization of a composite number. Yes. See here, the question says which factors are not included in the prime factorization of a composite number. So here we have to take composite number. Take one example. Composite number 6 is a composite number. Okay. So which factors are not included in the prime factorization? Prime factorization means 2, 3, 5, 7. These are the prime numbers. While we are converting C here. So we are taking the factors of 6. 2 3s are 6. We know that 2 3s are 6. Just before I explained that it will taking a prime factorization, don't take a composite number or don't multiply with 1 into 6. See here, if we will take 1 into 6, again we have to do 1 into 6. Again, same procedure, it will repeat. So, this method is wrong. This is correct because we are doing here prime factorization. Prime factorization is nothing but we have to take a prime number only. See here 2 3s are 6. Here 2 is also prime number, 3 is also prime number. Which number we are not taking? Yes, we are not taking this one. See here. Again 1 into 2? No. 1 into 3? No. So which number we are not taking means 1, we are not taking 1. So here the answer is 1. Because 1 is neither prime nor number. So which factors are not included in the prime factorization of a composite number? So the answer is 1. 1 is not included in the prime factorization of a composite number because 1 is neither prime nor composite number. Okay, keep in mind. Next, move to fourth part. Fourth question, write the greatest 4-digit number. Fourth question. Write the greatest 4-digit number and express it in terms of its prime factor. Terms of its prime factors. Prime factors. See here what the question says. Yes, write the greatest 4-digit number. We have learned in small classes greatest 4-digit number, greatest 5-digit number, smallest 4-digit number, smallest 3-digit number. We know that. Okay, in numbers which is greater number, 9 is greater number. We know that. Okay, so we have to take 4 digits greater number. So this 4-digit greater number 1, 2, 3, 4 digits, and the numbers are greater. So this is 4-digit greater number. So write the greatest 4-digit number we already wrote and express it in terms of its prime factorization. Means we have to write the prime factorization of 9999. Okay, here I will show you two methods of this. Okay, first one is 9999. See, prime factorization we have to multiply with prime number. 3 means 3333. If we multiply this prime number 3 with 3333, we'll get 9999. Multiply and see. 3 3s are 9, 3 3s are 9, 3 3s are 9, and 3 3s are 9. So 3 into 3333 is nothing but 9999. Understood? So next, this is prime number. So we have to stop left side like this. Here we have to stop. Next, again 3. Yeah, 3 into 1111. Multiply this 3 ones are 3, 3 ones are 3, 3 ones are 3, 3 ones are 3. So here also we are getting a prime number. One is prime number and another also prime number. Here the 3333 is a not prime number, so we have to take a factor again of this 3300. We'll do 3 into 1111. Here this is also prime number, this is also prime number. Next, yeah, continue this. Okay, how we have to multiply this? Yes, see here. Multiply 100. 11 ones are 11. One carry 11 0 0. 1 11 ones are 11. So if we will multiply 101 into 11, what we have to get? Yes, 1111. So here 11 and 1001. Multiply this two, we will get 1111. Here 11 is also prime number and 101 is also prime number. But see, check out whether 101 is getting a factors more than 2. No, because this is not a composite number. This is a prime number, so we have to stop here. See here. Here also prime number, here also prime number, this is also prime number, this is also prime number. So the solution stop here only. Okay, stops here only. 9,999. What they said, we have to take the factors of 9,999. Prime factorization means at the end we will get all prime numbers. So if you will multiply 3 into 3 into 11 into 101, what we will get? Yes, 9,999. Check it, multiply and check it. Okay. So this is your answer. Another way to solve this, let's play. See here, 9,999. Prime factorization means we have to divide with prime numbers only. We have to divide with prime numbers only. Keep in mind because they ask prime factorization. Prime factorization means we have to divide with prime numbers only. Don't divide with 9 into 1, 100 because 9 is not a prime number. If you want to divide like this, we have to start with 2. If the last number is even numbers, then divide with 2. Otherwise, if the last number is odd, divide with 3. If the last number is 0, divide with 5 or 2. Okay. So like this we have to divide. Let's check this one. Yes. 3,333 is the 9,999. Next. 3,111 11 101 101 So this is how we have to divide. There are two methods of prime. If they will ask prime factor 3, so you have to write this only. Otherwise, they ask write the prime factorization of 9,999. So we have to divide like this. Keep in mind here the numbers should be in prime numbers only and multiply these 3 into 3 into 11 into 101 you will get 9,999. So this is your answer. Okay, multiply with prime numbers. If possible, take two prime numbers. Otherwise, if not possible, take one prime number and another one is composite number. Then take the composite number of factors and prime numbers. At the last you will get prime numbers only. So this is your solution. Okay, coming to the fifth question. See here, the fifth question is, take fifth as a homework because similar to this problem. Okay, take fifth as a homework. Write the smallest 5-digit number. Write the smallest 5-digit number and express it in the form of in the terms of its prime factors. Similar to the previous problem. In previous problem, what we have done, what the question says, yes, largest, okay, greatest 5-digit number. In previous problem, greatest 4-digit number 999 is the greatest 4-digit number. But here, the smallest number 00000. This is the smallest 5-digit number. No, because in smallest we have to take 1 first, then 1, 2, 3, 4. 1, 2, 3, 4, 5. There are 5 digits. So smallest 5-digit number is 10,000. Keep in mind, divide this 10,000. Take what prime factorization. Okay, 10,000. So smallest 5-digit number. Okay, take this homework and send it to my WhatsApp number. Coming to the sixth part. Find all the prime factors of 1729 and arrange them in ascending order. Now state the relation if any between two consecutive prime factors. Right? Factors. See here what the question says. Yes. Find all the prime factors of 1729 and arrange them in ascending order. First we will solve up to here. Then later we will see what other questions. Okay. So what is that? We have to solve. We have to take the prime factorization of this number. First check it divisible by 2 because 2 is the smallest prime number. No. With 3, see 9 plus 1 10, 10 plus 9 19. 19 is not coming in 3 table because the rule of 3. What is that? Add all digits, then the answer. If the answer is divisible by 3, then the whole number is divisible by 3. But here the sum is 19, so the 3 is not divisible by this number. Okay. So take another number 5. No, 7. Yes, divide with 7. Okay. 7 to the 14. 17 minus 14 is 3. So 32. Okay. 7 3 is the 21. Some number is not divisible by 7. Next, we have to check 13. 13 is also prime number. 13 ones are 13. Remaining how much? Multiply 19 with 13. 3 nines are 27. 3 ones are 3. 4 5. 1 nines are 9. 1 ones are 1. 7 4 1. Yes. 13. 19 are 247. Next, 19 also prime number. So 19 ones are 19. See here once again I will explain. 7 2s are 14, but here there is a 17. So how many remaining? 14 3. Next 7 4s are 28. Remaining 4 here. 7 7s are 14 9. Okay. Next we'll check whether this number is divisible by 7 again. No, this is not divisible by 7. 8 no. 9 no. 3 no. 10 11 12 and last 13. 13 ones are 13. Remaining how much? 14 15 11. So 13 9s are 170 and 19 ones are 19. 7 is also prime number, 13 is also prime number and 19 is also prime number. So see here, we have to arrange this in which order? Ascending order. So ascending means we have to take smallest to biggest. Descending means biggest to smallest. So here the question says we have to arrange these numbers in ascending order. So we know that we have already solved in ascending order. So write 7 into 13 into. Okay, up to this is over. Next, coming to the next part. Now, state the relation, if any, between two consecutive prime numbers. Consecutive means continue. What is the meaning of this? Consecutive number, continue. Consecutive means continue. So here, after 7, the 13 is a consecutive number. See here, I will write prime numbers. 2, 5, 2, 3, 5, 7, 9 is not a prime number. 11, 13, 14 is not a prime number, 15 is not a prime number, 16 is not a prime number. And 9, 16, 17, 19. So up to 19. See here, 7 after, one number left. 13 after, one number left. 19. Okay, so 19. What is the relation here? What we are observing? See here, subtract 13 minus 7. 6. Subtract this, we'll get 6. And subtract 19 minus 13, that is 6. What we are getting here? Yes, the difference is 6. Between two consecutive prime numbers, the difference is 6. Okay, understood? So what is the relation? We are getting the difference is 6 between these numbers, these prime numbers. So this is your answer. Okay. Other method saying we have to factorize with factor G. Same procedure. Okay, same method. 7 into 13. Sorry, 247. 247. 7 is prime number, so we have to solve that. Next, 13 into 19. So 7 is also prime number, 13 is also prime number, 19 is also prime number. This is one another method to solve. Okay. Understood? Next. Seventh question. The product of three consecutive odd numbers. The product of three consecutive numbers is always divisible by always divisible by 6. Verify this statement with the help of some examples. With the help of some examples. See here, the question says the product of, here the product means multiplication of three consecutive. Consecutive means continue numbers. We know that numbers is always divisible by 6. Verify the statements with the examples. We have to take some examples and verify whether this statement is true or false. Okay, take consecutive numbers means continue number. Take any number, continue. If you take 1, 2, 3. If you take 2, if you start with 2, 2, 3, 4. If you start with 4, 4, 5, 6 means continuous number. Okay, any number you have to take continuous. If you take 6, 6, 7, 8. Okay, 3 numbers. You have to take 3 numbers continue. So, for example, 2, 3, 4. Take consecutive numbers. Continue number. 2, 3, 4. Continue number. And product means we have to multiply this. Multiply 2 3s are 6, 6 4s are 24. So what this says, the number is always means always divisible by 6. 24 in 24, 6 table 24 is coming. Yes, the 24 is divisible by 6. 6 4s are 24. So the number is divisible by always divisible by 6. Let's take some another example. Take your 6, 7, 8. Continuous number, 3 numbers continue and product means multiply this 42, 42, 8. 6 7 are 42, 42 into 8. 8 2s are 16, 1 carry, 8 4s are 32, 33. Yes. What we have to get? Yes, we are getting 336. What is the rule of 6? If the number is divisible by 2, yes, because the last number is one's place is even number, so the number is divisible by 2. And what is the rule of 6? Yeah, if the number is divisible by 2 and 3, then only the number is divisible by 6. See, 3 plus 3, 9, 6, 6 plus 6, 12. So, the sum of these numbers is 12. 12 is divisible by 3? Yes, 3 4s are 12. So, if the number is divisible by 2 and if the number is divisible by 3, then the number is, obviously, the number is divisible by 6. So, this statement is true. Verify this statement with examples. If you want to take another example, you can. Don't write these examples only. If you want to take 11, 12, 13, 20, 21, 22, so on. So, your wish. Multiply and check whether the answer is divisible by 6. Okay, what is the rule of 6? Yeah, the number is divisible by, if the number is divisible by 2, if the number is divisible by 3, then the number is divisible by 6. So, this is your solution. So, what we are observing here? Yes, what we are observing? In this, one even number, one or two even numbers. We are observing even numbers, and what we are observing yeah, the sum of all is divisible by multiples of 3. Multiples of 3. Multiples of 3. What we are observing this? Yeah, we are getting even number and the multiples of 3. That is the rule of 6. We are getting even number and multiple of 6 is nothing but the rule of 6. Okay. So, obviously the number is divisible by 6. Okay. So, this is your solution. We'll continue next class. Hope you understood. If you have any doubt, please ask me. And please write your homeworks, complete your classwork, homework book, and send it to my WhatsApp number. So, we'll continue next class. Thank you.